you're going for a combination, correct? Where a land should behave like a water or a water should behave like a land. What is very practical is what water behaving like a land. So when exactly does water will behave like a land? Only if this water body is surrounded by land, it will have its character, correct? So that's what we call them as what marginal water body, right? And my dear friends, when I talk about this cyclone is a circulation. What makes it as a circulation is what Coriolis force. Okay, right. So given all these preconditions, not all the tropical regions of the world encounter this. Say for example, cyclones. Only limited 7 geographical locations of the world experience this tropical cyclones, my friend. Gulf of California and Gulf of Mexico in North America, we said. Mozambique Channel, Arabian Sea and Bay of Bengal on Indian Ocean side. South China Sea, see, though I am calling it as a South China Sea, it can extend, right, as north as Sea of Japan, am I right? And say for example, right, till that region of Thailand, it can extend, am I right? And Australia, Gulf of Carpentaria, Australia, these are the places which experience what? Right, tropical cyclones. But the cyclone is known by different names in different regions. North America, you call them as hurricanes. Indian Ocean region, you call them as cyclones. South China Sea, you call them as what? Typhoon. Right, and Australia, you call them as what? Willy Willies, right? So they take different names at different places, right? And we also said that how exactly this cyclone looks like, structure of cyclone. All right, right, my dear friends. And somewhere I said, right, every cyclone, tropical cyclone, will be having an eye, and eye will be surrounded by eye wall. Correct. As you increase the distance from the, say for example, center of the eye or eye wall, right, the rain intensity decreases, the wind velocity also decreases. Correct? Right, my friend. And somewhere I said, right, the size of the cyclone. What is the size of the cyclone? Generally, what will be the size of eye? Everything we said. And I also talked about the character of an eye. Right? What exactly this eye is known for? Generally, we say eye is that central mechanism which controls the entire cyclone, right, as a circulation. Cyclone is known for heavy precipitation and very high wind velocity. But ironically, when I talk about eye is known for windless condition. Eye is known for rainless condition. Okay, right. On the other hand, right, we also talked about the dissipation of cyclone. Correct. When talk about dissipation of cyclone, how exactly cyclone is coming to an end. Right. See, for example, any system which has a genesis will have a dissipation. Correct. So cyclone is a short-lived mechanism. Cyclone is short-lived. See, for example, here, one more point you can add between this tropical and temperate cyclone. What is that point? Any intense pressure system or any intense weather mechanism is short-lived. Okay. So if you want to compare tropical and temperate cyclone, and somewhere, if you're asking me, which is comparatively long-lived, right? Temperate cyclones are long-lived because temperate cyclones are mild in its weather mechanism. Okay. So temperate cyclones, generally, they exist for more period. Right, or I say tropical cyclones normally 4 to 5 days, extraordinary condition I said 7 to 10 days. Okay, whatever be the case, weeks time. But temperate cyclone can extend for a fortnight's time, 2 weeks time it can extend. All right. So my dear friend, in duration, temperate cyclones are comparatively longer than tropical cyclones. Okay. So we talked about the dissipation of the cyclone finally, and I said dissipation of the cyclone starts with the landfall. What is landfall? Eye of the cyclone entering the land, not cyclone entering the land. No, eye of the cyclone entering the land. You know, the center of the cyclone. It means only when half of the cyclone almost crosses this land, you call them as what? Landfall. It is not that outer margin touching, no. Right? Eye should cross. Eye should enter. That's what you call them as what? Landfall. Okay. So we understood what exactly is a landfall. So with the landfall, what will happen? The friction will increase. If the friction is increasing, the velocity will increase. Simple. Correct. Similarly, my friend, when I talk about cyclone entering the land, supply of moisture will be restricted. Right? With a lack of moisture, cyclone will not get intensified. Now it will slowly start dissipating. Right? Right, my friend. So this is where we have stopped in the last class. Okay, see, yeah. What are the topics we just left? Temperate cyclones also, I'll just give you an idea. Right? Today we'll just talk about the temperate cyclone. And more than everything, today we are going to discuss about monsoon as a mechanism. See, nobody understands monsoon. Nobody. Even meteorological department, right? Let it be WMO or means IMD, whatever it is. Indian Meteorological Department or World Meteorological Organization. Right. Nobody understood monsoon in totality. All right. So we are not going to understand monsoon. We are going to understand the mechanism of monsoon. Okay. The erratic nature of the monsoon can be associated with some of the phenomena what we have in Pacific and Indian Ocean. Right. But we are not going to discuss about the details of monsoon. We are just going to understand the mechanism of monsoon. Okay. Right. So before that, what we'll do, right? We'll discuss this very small topic called as temperate cyclones. Temperate cyclones. See, today only one session of class we'll be having. Okay. So we'll be covering only monsoon today. Okay. So one topic will be left behind. That is world climatic classification as a topic will be left behind. Right. If possible, I'll just give you an introduction. Right. With that topic, climatology should be over. Okay. So if, yeah. So only one session, as I said, my friend, we've actually planned till 12. Right. We'll be having only one session. Maybe I'll extend up to 11 o'clock as right. Right. Maybe I'll just try to cover monsoon by that time. Okay. Right, my friend. Now comes temperate cyclones. Okay. Tropical cyclone in all sense we have seen. Okay. Now we are going to talk about temperate cyclones. Right. If you ask me, temperate cyclones, this temperate cyclone is known by different names, my friend. Say, for example, we said, right, the cyclone is called as mid-latitudinal cyclones. You call them as what? Mid-latitudinal cyclones. You call them as what? Extratropical cyclones. You call them as what? Extratropical cyclones. You call them as what? Wave cyclones. Right? It goes by different names. Temperate, mid-latitude, extratropical. It goes by different names. Even I think we have also used more names, right, in the last class. Okay, when it comes to okay, frontal cyclone. Okay, sometimes you also call them as what? Frontal cyclones. Okay. Now here, what exactly is this cyclone, temperate cyclone? We'll just understand, my friend. Okay. See, normally any low pressure system, slightly if it get intensified, and say for example, I told you, right, it means when I talk about the wind speed is slightly right on the higher side, they call them as what? Cyclones. Okay. All this, say for example, when I talk about this classification of the cyclone, if you remember, I was talking about this WMO's classification. This WMO's classification is actually applicable only to the tropical cyclones. Temperate cyclones, if I'm not wrong, the velocity of the wind is not taken into consideration. Okay, so the low pressure system along the mid latitudes, generally you call them as what? Right, temperate cyclones. Right, as you know, it is also called as frontal cyclones. Frontal cyclones. Now, my dear friends, already, say for example, we talked about the pressure belts of the world. Okay, we talked about the pressure belts of the world. Am I right? Say for example, few classes before, right? We were talking about the pressure belts of the world. Okay. Right here, right? We talked about the planetary winds. We talked about the planetary winds. Yeah, coming to this pressure system, pressure system. The 60-degree latitude is normally, often it is called as mid-latitudes. Every latitude has a name for it. Okay. In that regard, when talk about this 60-degree latitude, both the hemisphere, this particular latitude, you call them as what? Mid-latitude. In climatological parlance, you call them as what? Mid-latitude. Okay. Now this is a low pressure system. Am I right? So somewhere we are going to talk about the, say for example, phenomena, what exactly happens here. America. Say for example, I'm simply going to talk about the low. See, because I understand this is the place where I have this subpolar low. This particular latitude, very popularly called as mid-latitude. Okay, mid-latitude. So the phenomena, what is going to happen here, we are going to call it as what? Right. Say for example, mid-latitudinal cyclones or temperate cyclones. Okay. What exactly happens? My dear friend, this is the place, right? 60-degree latitude, temperate cyclone location. Okay. This is the place where two contrasting air mass will converge with each other. See, one side you have this polar wind, another side you have this trade wind. Okay. Now, if you ask me what exactly is the nature of this polar wind, my friend, see, for example, polar wind is converging with each other. Polar wind is extremely cold, correct? Because they are coming from polar regions. And westerlies, sorry, excuse me, I told trade wind, sorry, kindly excuse me, westerlies. Okay. So when I talk about westerlies, right, they are coming from the tropical region. Am I right? Right, tropical regions are warm region. See the beauty, right? Or say, for example, see what exactly is happening here. When I talk about temperate latitudes, right? When I just talk about temperate latitude is the place. Say, for example, this is the place. Right? Say, for example, I'm just talking about the presence of subpolar low. I have a pressure system called a subpolar low. Correct? It's a low pressure system. We know that. Okay. Now, say for example, from this subpolar low, right, from two different places, right, you have slightly. I'm just making it bigger, so we'll understand. Right, my dear. See, for example, somewhere around 60-degree, what you have is what subpolar low. Right? You have something called a subpolar low. Right. 90-degree, I have polar high pressure system. Okay. And somewhere around 30-degree north and south latitude, I have something called a subtropical high pressure system. Right? You call them as what? Subtropical. Okay. Subpolar low and subtropical high. Now you always know wind flows from what? High pressure to low pressure. So my dear friend, what happens? Right? From polar regions, I have an extremely cold wind, say for example, approaching the lower latitudinal location, right? Am I right? This is how it approaches, my friend. Okay. This wind, right? You call them as what? Cold polar winds. Of course, it is polar, right? Coming from the polar region, you call them as what? Polar wind. If you ask me what exactly is the temperature, I would say extremely cold because it is coming from one of the coldest possible latitude of the world. Am I right? You call them as what? Cold polar wind, my friend. Cold, right? Polar wind. Okay. On the other hand, I understand, right? A wind, right, which comes from the tropical region. This wind, you call them as what? Westerlies. If you ask me what exactly is the nature of this wind, they are very warm, right? Warm westerlies. You call them as what? Warm westerlies. See, so this is the place where extremely cold polar wind and relatively, or I should say, extremely warm westerlies are converging with each other. Two contrasting air masses trying to converge with each other. My dear friends, what will happen if two contrasting air masses trying to converge with each other? They do not converge readily with each other. Okay, because they are contrasting in nature. They are highly contrasting in nature. So as the case, what happens? They create a clear-cut boundary between them, right? They create a very clear-cut boundary between them, right? Something like an air curtain, right? Clear-cut boundary between them. This clear-cut boundary between them, right? You call them as what? Front. You call them as front. You call them as what? Climatic front, or simply you call them as what? Front. Okay. Right, my friends. So what is a front? We have an idea. See, already we have discussed. I do not know whether, right? Say, for example, earlier class we have discussed or not. Okay. Assuming that we would have discussed it. Okay. Now, how exactly a front is created, we have an idea. Now, my dear friends, you can, most of the places you can see the front. Front is more like an air curtain. Say, for example, one side it is warm air, another side is cold air. Am I right? Now, my dear friends, if you want to extend the story, you can extend it. How, say, for example, if you ask me what will happen to this warm westerlies, see, warm westerlies being less in density will start climbing over this polar front. Once it starts climbing, and you know that anything which climbs will go for condensation. Condensation will be resulting in what? Precipitation. Am I right? My dear friend, if you remember, even yesterday's class we have seen that. Correct. Right. Even yesterday's class, we're talking about this frontal precipitation, if you remember. I told you, right? What you will be having is a cold front. Right. Over this front, the warm air mass rises. See, somewhere here. Okay. Now, see this phenomena, what I was explaining. Number of occasions you will come across. Say, for example, temperature inversion, you'll be studying about it. Frontal precipitation, you'll be studying about it. Formation of taiga forest and precipitation happening throughout the year, you'll be studying about it. Frontal fog, you'll be studying about it. Now, frontal cyclones. So, this phenomena is very, very important. Okay. Right, my friend. So, what is a front? We know. Where exactly this front happens, that also we know. Okay. Now, my dear friends, I have just shown you in a two-dimensional representation. But you have to see, for example, see, my friend, imagine that it is three-dimensional in nature. See, my hand is this front. Okay, this front. One side warm air mass, one side cold air mass. Now, what happens is cold air mass will start pushing this warm air mass. Am I right? Because cold air mass is more density or more in density, right? It will start pushing this warm air mass. At one point of time, what happens because of this push? This front will get divided. Am I right? I have a stable front. The stable front will get divided, and the stable front will go for a circulation, right? The circulation of the stable front is what you call them as what? Temperate cyclones. Okay, right. See, understanding temperate cyclone is not so important, but understanding this front is important. Understanding what happens at this latitude, that is important. Am I right? So, my dear friends, once you know that there comes the, say, for example, the formation of a stable front, right? Now I'll tell you what exactly happens. Say I'm bringing both this two-dimensional representation, right, as well as three-dimensional representation. So whichever is comfortable, right, for understanding, you can take this in. Right, I am just copying too many images. Okay, but I just want you to take, say for example, only one or two. Okay, right, one or two. Okay, I will tell you that what exactly you have to select. See my dear friends, first, say for example, maybe I'll just take for example this particular, right, image, my particular image. See for example, as I was saying, the very first stage, right, you have the creation of a front. What is a front? I told you, right? It is more like an air curtain. One side, what you have is a warm air mass. This warm air mass is nothing but what warm westerlies. Am I right? Another side, what you have is what cold air mass. The front is created. Now I told you, right? It means this front. See, for example, warm air mass is less in density, so no problem. This warm air mass will always try to climb over this cold air mass. That's okay. But this cold air mass will try to, say, for example, venture forward. Am I right? It will try to push this warm air mass. Correct. As the case, what happens? Right. It becomes a kind of a wave. When it tries moving further, right? This cold air mass will start moving further. Slowly, steadily, it becomes a wave-like structure. That's the reason it is called as wave cycle. Right? So once it becomes a wave, at one point of time, this front will break. All right. This front will break. This is what you call them as what frontolysis, or you call them as what division of a stable front. All right. You call it as a division of a stable front. This is the place where you will be finding this front breaks. Say, for example, very carefully, if you look at this diagram. Here, I don't have any differentiation between cold and warm front. See, normally cold is represented by blue color, warm is represented by red color. This is universal color coding. Okay. Now, very carefully, if you see, my friend, you will be finding that alternate red and blue here, correct? Very carefully, you see it, right? Very carefully, if you're seeing here, you will be finding this alternate red and blue. It means what is the boundary of the cold air mass is also the boundary of the warm air mass. That's the idea. Am I right? But here it is not the case. The stable air mass is now getting divided. The stable air mass is becoming cold front. Right, or the stable front is becoming cold front and warm front. Am I right? Somewhere you can find. And my dear friends, what goes for a circulation, warm front cannot go for a circulation. What goes for a circulation is only the cold front. Am I right? The circulation of this cold front is what very popularly you call them as what? Temperate cyclonic circulation. Right? See, my dear friends, here again, right? Assuming that you are seeing the aerial view. Cold polar and maritime tropical. Forget about this MT and CP, right? Cold polar and warm westerlies converging with each other, right? Forming a stable front. Now the stable front is getting divided into cold front and warm front. Am I right? It's getting divided into cold front and warm front. Now this cold front is going for a circulation. Am I right? Slowly, steadily, it is going for a circulation, right? At one point of time, this warm air mass, right, will be having a minimum hold in the surface area, right? At one point of time, you will not have any warm air mass left in the surface area. When there is no warm air mass left in the surface area, that is the stage you say that cyclone is over, my friend. Okay. So make it very simple, right? What is this temperate cyclonic circulation? It is all about this front getting divided and further the cold front going for a circulation. Simple. Okay. Formation of a front, division of a stable front, then the cold front will go for a circulation. Right. This is all about this temperate cyclonic circulation. Right. What is that stage you have to remember and tell you? What are the different stages you have to remember and tell you, my friend? See, for example, okay. The last stage, okay, the last stage, normally you call them as what? Stage of dissipation, right? Cyclone, tropical cyclone also we have seen this stage of dissipation. The stage of dissipation you have to remember, correct? Just before the stage of dissipation, you have the stage of occlusion. Occlusion, right, is the just immediate step that, say, for example, comes before dissipation. Am I right? These two last stages you have to remember, right? dissipation or occlusion followed by dissipation. If you ask me, okay, what about the few first stages, right? Number one, creation of a stable front. Number two, division of a stable front. Okay, you forget about all these things, right? If I want me to say, for example, put it in stages, what exactly happens, right? I'll put it in stages, my friend. Stage number one, right? Stage one, right? Formation of a stable front. Formation of a stable front. If you want to include the wave format, you can include it. Otherwise, simply take it as stage two. Stage two, right, is division of a stable front. Division of a stable front, right, into cold and warm front. This is second stage, right? Now, what is the third stage? Right, circulation of this cold front. All right, circulation of the cold front, because I told you warm front will not go for circulation, right? Stage number four, if you ask me, what is the stage four? Stage four is occlusion and stage five is dissipation, right? Stage four is occlusion. Stage of occlusion. And stage five is stage of dissipation. Stage five is dissipation. Okay. See, few books says there are 6 stages, few books says there are 5 stages. Never mind about the number of stages. Okay. So what is temperate cyclonic circulation? We have an idea. Temperate cyclonic circulation can have its influence both over land and water. Right? Temperate cyclonic circulation will be happening in both the hemispheres. Okay. So with this, somewhere we are just completing this temperate cyclonic circulation. Just want to tell you that, see, for example, here, again, a useful image, right? Just telling you that, say, for example, temperate cyclonic circulation can occur both over land and water. Okay, see, here it is over land, right? Here it is over water. Okay, here it is over water. It's occurring both in northern hemisphere as well as in southern hemisphere. Okay, right, my friends. So with this, we are just completing this temperate cyclonic circulation, right? So the basic essence of temperate cyclonic circulation we have seen, right, my friends. Now, what we'll do, we'll just move to the last topic, tidbit topics, but very important topic. This topic, you call them as what? Monsoon, my friend. Monsoon. Right. Monsoon. Okay. Now, if you ask me what exactly is the literal meaning of this word called as monsoon, right? Say, for example, normally monsoon means, right, reversal of. Okay, Arab scholars are the one who has identified this mechanism called as monsoon. They have discovered this. All right. So, they, for example, even the name came from this Arab words. So, Arab scholars, right, they are the one who have identified this mechanism called as monsoon, right? Discovery of this mechanism. Okay, discovery of this mechanism. For the first to study in detail, Arab scholar. That's the reason even the word monsoon came from this word called as mawsum. Right, mawsum is actually an Arabic word which is also finding its place in Hindi. Am I right? Mawsum means they call them as what? Weather, whatever it is. Okay. Now, what exactly is the literal meaning of this word called as monsoon? If you ask me, monsoon, right, literally means, right, or I put it right, what exactly this monsoon is all about? Monsoon, right, is all about, right, seasonal and regional reversal of wind. seasonal and regional reversal of winds. Now, why you say that it is seasonal and regional reversal of wind? For example, finest example, take the case of India. India is one of the most prominent places in the world which experience monsoon. If you ask me, is only India experience monsoon? No. Parts of Australia experience monsoon. Part of Africa also experiences monsoon. Florida Peninsula experience monsoon. Am I right? But India, even South China, I mean, say for example, Southeast Asia, China also experience monsoon. India is the most prominent location among all. Am I right? Okay. Now, why I say seasonal and regional reversal of wind? The word reversal of wind is very important. Okay. Reversal of wind. Okay. Why this reversal of wind is very important, I'll tell you. See, for example, let us talk about monsoon. Take the case of India itself. Say, for example, for certain period, right, this wind will be flowing in what? Just over India, right? Wind will be flowing over India in a southwest direction. Right? Okay, I'll put it this way. See, my dear friends, as I said, say for example, at one point of time, I'll be having a wind, right, which flows over India in southwest in direction. Okay, that's what very popularly you call them as what? Southwest monsoon. Okay, you call them as what? Southwest monsoon. Okay, one point of time. Okay, one point of time, as I said, you will be having a wind which flows in a particular direction, southwest in direction. You call them as what? Southwest monsoon. Okay, southwest monsoon. Say, for example, another period of time, right, I'll be having another wind which is flowing in opposite direction, right? This wind, very popularly, you call them as what? Northeastern monsoon. So, what I understand, region is same, correct? But during different season, the wind is flowing in different direction. So, that's the reason we said seasonal and regional reversal of near about 180 degree, you have the change in the direction of this wind, opposite direction during different seasons. This reversal of wind, you call them as what? Monsoon. Okay, that's it. Okay. So what is the meaning of this word monsoon? Who discovered it? Right. What is the, say for example, what exactly the reversal of wind means? Everything we have an idea. Now here what we have to discuss about, we have to understand the mechanism of monsoon. What is this monsoon? Why do we have monsoon? Okay. So my dear friends, right. Before understanding this monsoon as a mechanism, right? Few things you have to keep or you have to understand. Few things at the very initial stage. See, for example, earlier classes, right? I was talking about IPCZ, my friend, or ITCZ. What is IPCZ mean? Right? What is IPCZ? What do you mean by ITCZ, my friends? Okay, InterTropical Convergence zone, converge, yeah, good. See, ITCZ, yes, you call them as what? InterTropical Convergence zone, accepted. Okay, you know what is ITCZ, right? InterTropical Convergence zone. This ITCZ is otherwise called as what? Right, you call them as what? Equatorial low, my friend. See, for example, if you remember one of the class, right, what we have taken, I was just talking about this ITCZ. Okay. This ITCZ is nothing but what? InterTropical Convergence, right? This is the place where, say for example, right, two tropical winds will converge with each other. What are the two tropical winds that converge with each other? Say for example, I'm just giving you, right, a rough idea about this, my friend. ITCZ. What is this ITCZ? right? Equatorial low. Other name for equatorial low, you call them as what? ITCZ. Correct. But now comes the question. Is this equatorial low will always be present in equatorial regions? No. Right? They will keep shifting towards north and south, my friend. See, for example, this ITCZ, to be very precise, this ITCZ, right, exactly overlaps. See, for example, why there is a rising convection? Because there is a high temperature. Why there is high temperature? Because there is high insolation. Why there is high insolation? Because sun's vertical rays is falling at this place. Am I right? High sun position is falling at this place. Am I right? Now, this is what the idea is. My dear friend, this ITCZ overlaps with the concept called as thermal equator. It just overlaps with this concept called as thermal equator. Okay. What is thermal equator, if you ask me? All longitudes you take it, right? Say, for example, assume that there are 360 different longitudes out there. 360 different longitudes are there. See, number of longitudes are infinite. That's a different story. But you assume that, okay, somewhere around 360 longitudes, I'm just taking in whole number. Now, what you do on a day-to-day basis, say, for example, every longitude you take it, right? You mark that place with the highest temperature. Am I right? You mark it with the place with the highest temperature. Okay. And you say, for example, start connecting all these 360 latitudes. All these 360 latitudes, you just join it. What happens? You will get what? Thermal equator. Am I right? So, joining all the places of high temperature, my friends, I was just talking about this thermal equator. So, what is this thermal equator? Connecting all the places of the world means from different longitudes. Say, for example, maybe let me say, for example, randomly, I'm just taking some world map. Okay. Say, for example, this particular map comes with the latitude and longitude. Just to tell you that how exactly we are marking this thermal equator. Name itself says thermal equator, right, my dear friends? So when it says thermal equator, thermal means temperature, right? So when I'm just using this word called as equator, it means the places having highest temperature. Say, for example, take only the longitudes for that case, just to understand what exactly this thermal equator is. Okay. Okay. See, not necessarily that highest temperature is recorded at equator. To be very precise, highest temperature is actually not recorded at equator. It is recorded in tropical region, right? Northern hemisphere during its summers, respective summers, and southern hemisphere during its respective summers. Okay, assume that some given day, my friend, right? You are just marking this highest temperature, right, of all longitudes. Say, for example, right? Right. This is where you are marking something like this. Okay. You are just marking all the highest temperature, right? something like that. I'm just giving you an example. Okay, I'm just giving you an example. You are marking all the highest temperature of a day along this different longitude. After marking it, you are joining all this, right, places. Okay, all these places, right? So what you experience now, or what exactly you have it now, this is what you call them as what? Thermal equator. All right. So I hope you understand what is this thermal equator. Joining places, right? Joining all the places of highest temperature of each and every longitude, you call them as what? Thermal equator. Right. So thermal equator is the one which experience the maximum temperature of any given day along that particular longitude. Okay. See, this thermal equator will shift from time to time. Am I right? Okay, my friend. When we say, for example, assume, right? When the sun's vertical rays is moving towards Tropic of Cancer, this thermal equator will also, say, for example, move towards north. Right. When the sun's vertical rays is shifting towards Tropic of Capricorn, the thermal equator will also move towards what? South. Okay. So, my dear friends, wherever you have thermal equator, this is the place where you will have ITCZ. So, ITCZ goes hand in hand with thermal equator. ITCZ goes hand in hand with thermal equator. So, wherever thermal equator is moving, ITCZ will also move, because that is the place where you will be having this rising condition. Okay. Right. So, my dear friends, what is thermal equator? We know, right? And my dear friends, not only this ITCZ, just want to tell you, the so-called equatorial low is always not fixed at equatorial region, right? It is always not fixed at equatorial region. Okay. They will shift north and south. They will shift north and south. Okay. Now, my dear friends, when I talk about, say, for example, shifting north and south, when exactly they shift during north and when exactly they shift during south, I'll tell you. Right. Whenever the sun's vertical rays is shifting north, this equatorial low will also shift north. When sun's vertical rays is shifting south, the equatorial low will also shift south. Right? This is an idea. Now, my dear friends, not only equatorial low, all pressure belts shifts north and south. Very, very important. Every pressure belt will shift north and south. Right? So the next idea what I'm developing is very simple. Every pressure belt will shift north during summers and south during winters. All right. The only pressure belt which will not shift is what? Polar high. Polar high cannot shift. All right. Because polar high is already there in the highest possible latitude. It can only shrink. So polar high of northern hemisphere will shrink during its summer. During its winter, it will expand. Okay. Right. So with this, what is our understanding here? Only one thing we understood. What is that? Pressure belt will shift. Right. Approximately, I'll show you the shift of pressure belts. See, we will try to understand the assorted concepts. Then at one point of time, we'll bring all this assorted concept in an organized fashion. Okay. See this particular diagram. I'll go for this. So somewhere I want you to understand this pressure belts will shift from time to time. Okay. The respective summer and winter, this pressure belts will shift. Right, my friends. Okay. So here, again, I am concluding. When sun's vertical rays is shifting north, sun's vertical rays oscillates between Tropic of Cancer and Capricorn. You know that. Okay. March 21st equinox, sun's vertical rays will be over what? Equator. June 21st, the sun's vertical rays will move towards what? Right. Tropic of Cancer. June 21st is summer solstice. Again, September 23rd equinox. December, right? 22nd, right? What you have is what? Winter solstice. Okay. So the sun's vertical rays oscillates between Tropic of Cancer to Capricorn. So when the sun's rays is oscillating between Tropic of Cancer and Capricorn, this equatorial low will also oscillate along with it, but not to the same degree. Shift of north and south will be there, but not to that degree. That's what I'm just saying. The general shift of ITCZ between seasons will vary anywhere between 5 to 10 degrees. Am I right? So this much I have an understanding, my friend. Okay, this much I have an understanding. Now what I do? Monsoon is a mechanism that deals with this ITCZ, my friend. See, for example, monsoon. We have plenty of mechanism that is being explained. We have Adley's concept, we have Flon's concept, right? We have Monarch study, right? We have ENSO. I mean, plenty of concepts are there, but I'm just going for Flon's concept, right? Flon is the one who has given this ITCZ concept, my friend. Okay, we'll understand what exactly is ITCZ. Okay, now, my dear friends, one thing I understand, ITCZ is nothing but what? Intertropical Convergence Zone, the other name of equatorial low. Am I right? So let me give you this ITCZ. When I talk about this ITCZ almost becomes synonym with what? Right. The shift of sun's vertical rays. Okay. Now here, with the earlier diagrams, like, see, my dear friends, see, I'm just bringing this ITCZ here. Okay, Intertropical Convergence Zone. Where exactly ITCZ, say for example, is placed during the different, say for example, months of a year. What you are seeing is ITCZ of July, my friend. Normally the summers of northern hemisphere, right? And what you are seeing is ITCZ of January. ITCZ of July, almost this ITCZ is placed in northern hemisphere. ITCZ of January, almost this ITCZ is placed in southern hemisphere. Why? Because, right, summers, July, sun's vertical rays is near completely there in northern hemisphere, so the ITCZ is also shifting north, right? When I talk about, say for example, when I talk about January, the ITCZ has shifted south. Okay. So somewhere I understand there is going to be a significant shift in ITCZ. Okay. Now, we will take only this July ITCZ, right? July isobars or July ITCZ. What exactly is going to happen, we'll understand. Now, my dear friends, you may ask me, okay, sun's vertical rays is shifting in a uniform fashion. But why this ITCZ is not shifting in uniform fashion? There is a number of fluctuations here and there. Why? Because, number one, land and water divide. Wherever you have water, the fluctuation will be minimum. Wherever you have land, the fluctuation will be maximum. Because water maintains temperature. See, you are in water. If you are in water, right, only in water, north and south, if it is only water, the fluctuation is minimum, my friend. Okay. If you have land in between, the fluctuation is maximum. This is one, because water maintains temperature, right? This is one very important reason why this, say for example, fluctuation is not uniform, or the bend shift is not uniform. Okay. Generally, what happens? The IT season shifts 5 to 10 degree north of equator during summers. 5 to 10 degree, that is understandable. But what happened? If you ask me why there is an exceptional bend of ITCZ over South Asia, if you ask me, it is all because of size of Asia. Right, Asia becomes so hot during summers. Am I right? So this particular, say for example, extensive size of Asia is almost right, resulting in one exceptional bend of ITCZ over Indian landmass. Okay. Now, my dear friends, only this exceptional bend of ITCZ, if you put all that story, whatever I have said now, let me consolidate. Okay, number one, every pressure belt shift north during summers and south during winters. Okay, but what exactly is this one thing you have to understand here? There are 7 pressure belts, my friend. If you can correlate it somewhere, there are 7 pressure belts. Okay. There are 7 pressure belts, right? We have identified 7 pressure belts. Every pressure belt will shift north and south during their respective seasons. But what happened? Right. All this pressure belt, the shift will be within the same hemisphere, correct? But when I talk about equatorial low is an exception because, as I told you, during summers, this equatorial low is going to get placed completely there in northern hemisphere, and during winters, they are going to get placed completely there in southern hemisphere. Am I right? So equatorial low is going to have its shift between hemisphere. Am I right? Every pressure belt is going to have its shift only within the hemisphere, but equatorial low is going to have its shift between hemispheres. Okay, right. So during summers, it's going to place itself in northern hemisphere, and during winters, it's going to place itself in southern hemisphere. Right. This is another idea. Okay. And my dear friends, the third one, what I want to insist, right? The general shift of ITCZ is generally 5 to 10 degree north of the equator, but in Asia, over Indian subcontinent, an exceptional bend is registered. You ask me why there is an exceptional bend. This bend is all because of size of Asia. Till here you understand, my friend. If you can understand it till here, now I'll tell you what is this southwest monsoon. Okay, coming to the final conclusion. Now we'll understand what is this southwest monsoon. Right, my friend. I'm just reconstructing it, right, with the example of a world map. I'm just taking a world map. But even world map is not needed for us. Only the regional map, if it is there, right, that should be fine enough. This North American map is actually not needed for us. So let me remove this North American map. Only the map of Asia, I'm just taking it. Okay. Now we are just going to understand this mechanism right here. I'm just bringing this equator, my friend. Approximately, I'm just bringing this equator. Okay. Try to understand monsoon as a mechanism is very easy, right? Assume that this is equator. Okay. Now, my dear friends, I told you ITCZ generally shifts 5 to 10 degree north of equator. We know that. Okay. So I'm just say, for example, taking this 5 to 10 degree north, right? I'm just taking this 5 to 10 degree north. Right? Assume that this is our ITCZ. But you know the fact, right? You know the fact that there is one exceptional bend of ITCZ registered over India, right? Exceptional bend is registered over India, right? Okay. Say, for example, if you ask me, okay. Yes, my friend, I was just talking about this exceptional bend of ITCZ over Indian landmass, right? I'll call it as an exceptional bend. Okay. Why there is an exceptional bend, that also you know. This exceptional bend is due to the size of Asia. Okay. Exceptional bend of ITCZ is registered over Indian landmass. Okay. Till here, I understand. Okay. What is ITCZ? How much exactly they shift north and south, right? Everything I understand. And one exceptional bend of ITCZ also I have just taken. Now comes the question, okay, ITCZ. Okay. Now let me ask you this question, my friend. You tell me, right? What are the different wind that converge at ITCZ, my friend? ITCZ itself is the place where winds converge with each other. I just want to know what are the different wind that is actually converging at ITCZ. Right, that's a question what I'm just asking from my side. Right, what are the winds that is actually converging with ITCZ? Okay, southeast and northeastern trade. Well said. Okay. Now, if I just talk about this, say for example, this, okay, I'm just writing it as an exceptional bend. Now, southeast and northeastern trade wind are the one which is, say for example, converging with ITCZ. Okay, in that regard, okay, as somebody said, right? Southeastern and northeastern trade are the one which is actually converging here, right, with this ITCZ. Now, my dear friends, in that regard, right, say for example, let me bring this a northeastern trade, my friend. See, for example, northeastern trade is how this northeastern trade is converging. Okay, say for example. Right, this is my northeastern trade. Okay, so I don't have a problem. Northeastern trade comes from northern hemisphere. This is your northeastern trade. Okay, northeastern trade. Now comes the question. Okay, what is another wind? Another wind is southeastern trade. Sorry, excuse me. Right? Yeah. One is northeastern trade, another is southeastern trade. If you ask me where exactly the southeastern trade is coming, southeastern trade is coming from what? Southern hemisphere. Okay. This wind which comes from southern hemisphere, you call them as what? Southeastern trade. Southeastern trade. Okay. Now comes the question. ITCZ is now placed in northern hemisphere completely. Okay. So the southeastern trade, in order to confluence with ITCZ, the southeastern trade has to enter what? Northern hemisphere. But you know, on entering northern hemisphere, the Coriolis effectivity changes. Right. Southern hemisphere, the Coriolis deflection, the direction of deflection is towards left. But when it comes to northern hemisphere, the direction of deflection is towards what? Right. So what happens? As and when this wind enters the northern hemisphere, this wind gets deflected towards the right. And this wind, not exactly at equator, after crossing equator, this wind will start getting deflected towards the right, and this wind will be flowing as what? Southwest monsoon. Okay. You know, the wind is always named from which direction it is coming from. So which direction this wind is coming from? This wind is coming from what? Southwestern direction. So what is this southwest monsoon, if you ask me? Southwest monsoon is nothing but what? The deflected trade wind of the southern hemisphere. Okay. Right? One liner, my friend. Right? The deflected southeastern trade becomes southwest monsoon in northern hemisphere. Why? Simple. Coriolis deflection. Right? As and when it enters the northern hemisphere, it gets deflected towards the right and flow as southwest monsoon over India. Right? So, my dear friends, with this understanding, what you do, you kindly take one paragraph of answer writing. Am I right? Just kindly take one paragraph. So the entire process, I'll put it in one paragraph. Kindly take it. So entire thing, I'll just put it in one paragraph. You can write it. The complete story, I'll tell you. With the apparent shift of sun's vertical rays, with the apparent shift of sun's vertical rays, towards north, during summers, with the apparent shift of sun's vertical rays towards north during summers, the ITCZ also shifts north. The ITCZ also shifts north. The ITCZ also shifts north. The next line you can write it. ITCZ during summers completely places itself in northern hemisphere. In northern hemisphere. The general shift of ITCZ, is marked 5 to 10 degree north of equator. Is marked 5 to 10 degree north of equator. However, given the size of Asia, given the size of Asia, an exceptional bend of ITCZ, an exceptional bend of ITCZ is registered over Indian subcontinent, is registered over Indian subcontinent. This bend is even beyond Tropic of Cancer. This bend is even beyond Tropic of Cancer. So paragraph number 1, we have taken it next. Why there is a shift of ITCZ? Why exactly ITCZ having an exceptional bend over India? Why this bend is even beyond Tropic of Cancer? Everything we have taken. All right. Now you just come to the second paragraph. Second paragraph is all about what? How the southeast monsoon is southeast trade wind is actually becoming southwest monsoon. Okay. Come to the second means, right? Take the second paragraph. Right. So you kindly write it. No, you can write it. Okay. The southeastern trade of southern hemisphere. The southeastern trade of southern hemisphere in order to confluence with ITCZ, in order to confluence with ITCZ, eventually enters northern hemisphere. Eventually enters northern hemisphere. Further, you can write the southeastern trade on entering northern hemisphere, the southeastern trade on entering northern hemisphere, under the influence of Coriolis force, under the influence of Coriolis force, gets deflected towards right, gets deflected towards right, and eventually flows, as southwest monsoon over Indian landmass. Over Indian landmass. So my dear friends, what is this southwest monsoon? Approximately we have an idea. Okay. So in general, if you want to take a one-liner of the southwest monsoon, I would say southwest monsoon, one-liner. How do you understand the southwest monsoon? Southwest monsoon is nothing but what? Deflected deflected southeastern trade in northern hemisphere, you call them as what? Southwest monsoon. That's it. Okay. One line, if you want to bring it, it is deflected southeastern trade in northern hemisphere. Right? Right. This is one liner, right? Correct? Right. Okay. The rest of the story we know. Okay. Right, my friend. So, what is this southwest monsoon? We have an idea. Okay. Right. So, after understanding southwest monsoon, see, for example, when I talk about southwest monsoon as a season, like which season you experience southwest monsoon, it is right June to September. Am I right? Or you call it as June, July. June, July, August. June, July, August is nothing but what? Summer. Am I right? No. Right, my friends. That's the reason in midpoint I have just taken it as what? July. July is the middle of southwest monsoon. Am I right? Now, my dear friends, right, what we'll do, say for example, right, we'll understand what is this northeastern monsoon. Okay. The next we are moving to this northeastern monsoon. Right. So what is this northeastern monsoon? We'll try to understand. Okay. Now, my dear friends, if you ask me when exactly what is the period of this south means northeastern monsoon in India, right? Say for example, the month of September to December. No. September, almost September, middle of September, this northeastern monsoon will start. Okay. Now, what is this northeastern monsoon? We'll understand. Okay, September, what happens? I should understand. See, for example, okay, when I talk about this northeastern monsoon, September. You know one thing, when I talk about September, September 23rd is what? Equinox. Equinox. What exactly happens during equinox? We know. Okay, I'm asking you. You tell me what exactly happens during equinox. September or middle of September is the one northeastern. Right? Say for example, northeastern monsoon starts. Okay. For that, I should understand what exactly happens during the month of September. Okay. September is a month of equinox. Right? We know that. Okay. Now you have to tell me what is this equinox? What do you mean by equinox? Right. Climatology, the basic facts, assuming that basic facts you know that. What do you mean by equinox? Equinox literally means equal length of day and night. Now what happens in equinox if you ask me? During equinox, what happens, my friend? The sun's vertical rays will be falling over right equator. So what happened? This ITCZ almost overlaps with right equinox. Sorry, excuse me, equator. Right? Say for example, somewhere let me mark this is your ITCZ. So ITCZ, right, nearly overlaps with your right equator. Okay. Somewhere, just for a representational purpose, I'm just going for this. Okay. Assume that this is your ITCZ, right? This is your ITCZ. Okay. Now, what happens with the apparent shift of ITCZ towards south of India, right? And you know what are the wind that converges with ITCZ? Of course, I know that is one is northeastern trade, and number two is what? Southeastern trade. In that regard, right? Say for example, this is my northeastern trade. Right? This will be your northeastern trade. Another wind which is converging here will be your southeastern trade. Okay. So to make it very simple, the wind which once got displaced from India, what you call them as what? Northeastern trade, once again get re-established over Indian landmass. See, northeastern trade and southeastern trade. Right. Earlier case, northeastern trade has shifted north of India. Now this northeastern trade now gets once again gets re-established over Indian landmass. This re-established trade wind is what you call them as what? Northeastern monsoon. Okay. So what is the condition? Northeast monsoon is a normal condition, right? Southwest monsoon is a reversed condition and northeast monsoon is a normal condition. Okay, right, my friends. Okay. Now somewhere, if this you can somewhere correlate it, what happens with the sun's vertical or movement towards equator, when it is shifting towards equator, ITCZ also shifts towards equator. Okay. With the apparent shift of ITCZ towards equator, what happens? The displaced northeastern trade once again gets re-established over Indian landmass, right? This is what you call them as what? Northeastern monsoon. So kindly take it. One line I'll give you, right? One liner. If you ask me what is this northeastern monsoon in one liner, right? Right. Re-established trade winds. Re-established trade winds, northeastern trade, right, over Indian landmass, you call them as what? Northeastern monsoon. Okay, re-established northeastern trade. Okay, so somewhere you can write. By the month of September, come up. With the apparent movement of sun's vertical rays by the month of September, with the apparent movement of sun's vertical rays towards equator, the ITCZ shifts south of India. The ITCZ shifts south of India. The next sentence is, with the shift of ITCZ, come on, the displaced northeastern trade, once again gets re-established. Over Indian landmass. Once again gets re-established over Indian landmass. This re-established northeastern trade, is popularly called as northeastern monsoon. This re-established trade wind, or this re-established northeastern trade, is popularly called as northeastern monsoon. So my dear friends, what is southwest monsoon? We have an idea. What is northeastern monsoon? We have an idea. Again, let me tell you, in simplicity, what is southwest monsoon? I have something called a southeastern trade wind of southern hemisphere. The southeastern trade of southern hemisphere, on entering northern hemisphere, what happens? Coriolis effectivity changes. It gets deflected towards the right and eventually it becomes southwest monsoon. Why should it enter northern hemisphere? If you ask me, reason is very simple, because it has to converge with ITCZ, and now the ITCZ is there in northern hemisphere. That's it. Now what happens? Slowly and steadily, as the time passes, the ITCZ will shift towards equator. When ITCZ is shifting towards equator, the northeastern trade will start getting re-established over Indian landmass. Once if it gets re-established over Indian landmass, right, then that condition you call them as what? Northeastern monsoon. So northeastern monsoon is a normal condition. Southwest monsoon is a reversed condition. Correct? Right, my dear friends. So this is all about your monsoon as a mechanism. Okay. So what is monsoon? We have an idea. Now see, generally we say monsoon, right? Monsoon includes southwest as well as northeast. But by default, when I say monsoonal precipitation, we actually mean southwest monsoon. Why? Because 90% of this Indian landmass receive precipitation from southwest monsoon. See, here itself you can see, right? Southwest monsoon is more like an onshore wind. Am I right? It can collect the moisture, right, from the Arabian Sea or whatever it is the case, right? It can collect the moisture from the sea and it can deliver into the land. It is an onshore wind. When talking about northeastern monsoon is an offshore wind generally. It's slightly different. State of Tamil Nadu, the things are different. All right. Whatever be the case, maximum precipitation to India is brought by the southwest monsoon. That's the reason. By default, when we say southwest monsoon, like say for example, or I would say monsoon points southwest monsoon. Why monsoon? Without mentioning whether it is southwest or northeast, if somebody is saying monsoon, monsoon means southwest. Okay. Why? I have justified it. Okay. 75% of the annual precipitation and 90% of the land is covered by this monsoon, southwest monsoon. Okay. That season you will be having the wet spell of India, my friend. Okay. Right. Now, only thing is that sometimes what happens, this monsoon becomes success, or sometimes this monsoon becomes a failure, right? Now, what are the phenomena which, say for example, which aids this monsoon, which affects this monsoon? We'll understand. Sometimes what happens, you would have heard about this phenomena called as El Nino and La Nina, right? El Nino, La Nina, all right? El Nino and La Nina. Okay. So sometimes we'll understand that what exactly is this El Nino, what is this La Nina, which is favorable for India and which is unfavorable for India, we'll understand. Okay. So my dear friends, okay. So what we'll do, now we'll try to understand what is this El Nino and La Nina. And of course, we'll understand that how exactly it is going to affect what? Indian monsoon. Okay. So we'll understand this El Nino and La Nina. See, always we say, right, whenever the monsoon fails, you always say it is because of El Nino. Only thing is that I should understand what is El Nino, I should understand what is La Nina. Okay. See here, you would have heard about ocean currents. I will just bring you this ocean currents map, right? Or even in your atlas, say for example, you can refer this ocean currents map. Ocean currents map. Right. What is this ocean currents? Somewhere you should know it, right? Continuous flow of water. Like current means anything which is continuous, you call them as what? Current. Continuous flow of water in the ocean surface, you call them as what? Ocean currents. Okay. You call them as what? Ocean currents. Right. Now, my dear friends, somewhere you just try to, say for example, open this ocean currents map. Okay. Randomly, I'm just opening some ocean currents map here. Okay. Right. Randomly, I'm just opening this ocean currents map. See, for example, generally in oceans, right, ocean current, you find two types of current. One you call them as what? Warm current, and two you call them as what? Cold current. Okay. Now, my dear friends, read about this black colored one, right? Red stands for warm, blue stands for cold. Okay. Now, if you're there in your ocean currents map, world climate, if you go to your atlas, you'll be finding this section called as world climate. In this world climate, you'll be finding this ocean currents map. You find one similarity. What is the similarity? Any oceans you take it, any ocean you take it. North Atlantic Ocean, right? South Atlantic Ocean, Indian Ocean, North Pacific Ocean, South Pacific Ocean, any ocean you take it, you find one similarity. What is this similarity? Say, for example, if you're there in any ocean, right? The western side of this ocean will be warm current, and eastern side of this ocean will be cold current. With respect to oceans, I am just talking. Right? That's the reason always we say west is warm. Correct? Western side of the ocean is warm and eastern side of the ocean is cold. So, my dear friends, right? Australia also you find the similar one. Okay. So, western side of Australia will be warm. Am I right? Sorry, excuse me. What is west of ocean becomes east of land. Okay, Pacific Ocean, right? The western side of Australia, sorry, the western side of Pacific Ocean, that is Australia, that is warm, and the eastern side, that is the Peruvian side, it is cold. Right. Now, this is one. Number two, wherever I have warm current, adjoining land, the temperature will increase and it will become warm. Wherever I have cold current, the adjoining land becomes cold, right? Whenever the adjoining land becomes cold or this place becomes cold, this region becomes a high pressure, correct? And whenever I have a warm current results in low pressure, right? This is very normal. So where all you have warm current and cold current, right? And wherever you have cold current will result in high pressure. Warm current will result in low pressure. Simple. Warm current will increase the temperature. Increased temperature will result in low pressure. Now, my dear friends, this is one general understanding. Now here, I'll tell you, I'll just connect this El Nino and La Nina. My friend, when I just talk about success and failure of Indian monsoon, we'll correlate it. On what occasion it becomes a success and what occasion it becomes a failure, we'll understand. See, my dear friends, what is southwest monsoon? When talk about southwest monsoon, generally we know southwest monsoon is nothing but what deflected trade wind of the southern hemisphere. Am I right? This trade wind which is getting deflected in southern hemisphere. Okay. Right. See, for example, I just want to tell you on what occasion this monsoon will be a success and monsoon will be a failure. See, for that I should understand from where exactly this wind comes from. See, this wind, understanding says this wind, say for example, surpasses equator. Okay, this is what your southeast monsoon is all about. Okay. Southeast monsoon. So where exactly the southeast monsoon comes from, if you ask me, right? The southeast monsoon is nothing but what? Sorry, excuse me, there's not southeast monsoon, southwest monsoon, sorry. The southwest monsoon. Southwest monsoon is nothing but what? Deflected trade wind of the southern hemisphere. That is nothing but what? Southeastern trade wind. Okay. Now comes the question. Is this wind ultimately comes from Australia? If you ask me, no. This wind comes through Australia. Okay, but when I talk about the southeastern trade, the southeastern trade indirectly comes from, say, for example, Peruvian coast. They almost come from Peruvian coast. Okay, southeastern trade. Okay, so what I understand, the immediate source of southwest monsoon is southeastern trade of Indian Ocean. Okay, and the indirect source is southeastern trade of Pacific Ocean. Okay, it is a southeastern trade of Pacific Ocean. Okay, so it is something like a chain reaction what you have. Okay, see, for example, whenever I just talk about, see, for example, the wind that comes to India, it is coming from Australia, no denial about it. But I understand where exactly the wind comes to Australia. From where exactly the wind comes to Australia? From where it comes from, if you ask me, it comes from Peruvian coast. So what I understand, wind, there is substantial wind which is coming from Peru to Australia. And there is substantial wind that is coming from Australia to India. My dear friends, if this wind is going to get affected, certainly this wind is going to get affected. Okay. Normal condition, on a normal condition, if you ask me, normal condition, comparatively, don't go for absolute condition. Okay. Normal condition, Peruvian coast, what I have is a cold current. Okay, I have a cold current. If you have a cold current here, all right, normally if you have a cold current, okay, I'll be having a high pressure. Okay, so here, this Peruvian region will have a high pressure. Comparatively, right? Comparatively, my friend, Australian region will be having a low pressure. Okay, Australian region will be having a low pressure. Right, very good. This is one understanding. Comparing this Peruvian coast and Australian coast, I have this right high pressure at Peruvian coast and Australia having a low pressure. Why? Because this is a region where I have warm currents and this is a region where I have cold current. This is one. And if you're just comparing India and Australia, my dear friends, of course, Australia will be having comparatively a high pressure, right? And India will have a low pressure. Okay, India will have a low pressure. Okay, will have a low pressure. India will have a low pressure. Or at least I put it this way, right? Here, somewhere here you should have a low pressure. Okay. If this setup is there, right? This monsoon will be a success. Okay. So what I understand for India's successful monsoon, southeastern trade of Pacific Ocean and southeastern trade of Indian Ocean, both should be strong. But what happens during El Nino, the condition changes. Okay. This is a normal condition. What I'm just showing you is for successful Indian monsoon. Okay. Just remember here, my friend, the wind that comes to India, indirectly it comes from Peruvian coast. Now comes the question, what do you mean by El Nino? My dear friends, El Nino and La Nina, both I'll take it. Now, my dear friends, what exactly happens, I'll tell you. Say, for example, I was just showing you this ocean currents map, right? The earlier diagram, I was just talking about this ocean currents map. Okay. Now here, say, for example, take the case of this South Pacific Ocean. We are taking the case of South Pacific Ocean. When I just talk about the South Pacific Ocean, what I understand, I'm just taking the case of Australian coast and Peruvian coast. Australian coast is having a warm condition, warm waters, and Peruvian coast is having a cold waters. Okay. Now, understanding says, my friend, warm waters will be less in density, so the water will rise. Cold water will be having more in density, so the water will sink. So what happens? On a day-to-day basis, on a regular basis, what happens? There is a gradation difference that is experienced between Australian coast and Peruvian coast. Australian coast is elevated because it is warm water, it rises. Peruvian coast slightly it sinks because of cold water density difference, it sinks. So what happens? There is a slope that is created across this Pacific Ocean. Water very strictly maintains this water type of balancing. So what happens? This warm waters from Australian coast, right, will start traveling towards this Peruvian coast. All right. The waters, right, the warm waters from Australian coast will start traveling towards Peruvian coast. This you can see it, right? Why exactly it is traveling? Because Australia warmer side, Peruvian colder side. Okay. And say, for example, this journey, why exactly it is traveling only in equatorial region, not in the other region, if you ask me? Because other region you have this trade wind. Trade wind will be opposing the movement of this, right, water. All right. So it almost, say, for example, it moves in equatorial region. Right. At one point of time, my friend, this warm water will occupy the cold waters of Peruvian coast. So from the Australia, this warm water will be start traveling, and at one point of time, it will reach the Peruvian coast. At one point of time, this Peruvian cold current will be superimposed by this warm water. The Peruvian coast is superimposed by this warm water. This Peruvian current will go missing. So what I want to tell you, El Nino is that condition where the cold Peruvian current will be replaced by warm waters. So my dear friends, during El Nino condition, what happens, I tell you, right? This Peruvian coast will become warm. Comparatively, Australian coast will becomes cold. So Peruvian coast, when I just talk about Peruvian coast becoming warmer, all right, you will have the establishment of low pressure over American land and comparatively high pressure over Australian region. It means when this particular situation occurs, right, the trade wind will become weak. Because I understand, right, I cannot have a wind which moves from low pressure to high pressure. So during El Nino condition, what happens, my friend? The southeastern trade of Pacific Ocean becomes weak. Am I right? See the beauty, right? Here itself I'll write it. During El Nino condition, what happens? Right. During El Nino condition, what happens? Comparatively, Peruvian coast becomes a low pressure, right? And Australian coast becomes a high pressure. Australian coast becomes high pressure. As the case, what happens, my friend, right? This particular wind, right? This wind becomes very weak. Am I right? Okay. American coast becomes a Peruvian coast becomes a low pressure, right? And Australian coast becomes high pressure. As the case, the southeastern trade wind becomes weak, right? What you experience is a weak southeastern trade. If the southeastern trade of Pacific Ocean becomes weak, southeastern trade of Indian Ocean will become weak, and the southwest monsoon itself will become weak. Okay, so that's what happened during El Nino condition. Number one, you first understand what is El Nino. Number two, we'll understand how El Nino affects Indian monsoon. Okay. What is normal condition, my friend? Peruvian coast, right, will experience cold condition. Australian coast experiencing warm condition. This is normal condition. Because any ocean currents map you take it, this is how things will be. Am I right? So whenever this normalcy changes, you call them as what? El Nino. Am I right? So kindly write it. What is El Nino, my friend? In simplicity, you will write it. Okay. The cold Peruvian current. Kindly write it. Write the heading called as El Nino and kindly write it. The cold Peruvian current being replaced, the cold Peruvian current being replaced by the warm waters, sourced from Australian coast, is known as El Nino. I repeat, the cold Peruvian current being replaced by warm waters sourced from the Australian coast is known as El Nino. Further, you can write during El Nino, a low pressure gets developed over Peruvian coast. And relatively a high pressure gets created. Over Australian coast. As the case, either the southeastern trade of Pacific, the southeastern trade of Pacific Ocean, either becomes weak or go for a reversal, or get reversed. Either becomes weak or get reversed. The last sentence you can write. The weak southeastern trade of Pacific Ocean. Adversely affect Indian monsoon. Adversely means a negative impact, right? Adversely affect Indian monsoon. Okay. So my dear friends, what is this what is this El Nino? We have an idea. So how this El Nino affects Indian Ocean, that also you know. If it is weak southeastern trade, this southeastern trade of Indian Ocean also becomes weak, right? So Indian monsoon also becomes weak, right? Now, my dear friends, what is El Nino? We have an idea, right? What is La Nina? La Nina is nothing but what? Normal year, my friend. Sometimes you call them as what? La Nina. Okay. Now, what happens whenever the normalcy returns? All right. Whenever this cold Peruvian current get re-established over the Peruvian coast, the condition you call them as what? La Nina. La Nina establishes a very strong southeastern trade. All right, southeastern trade, right? And the strong southeastern trade will establish strong southeastern trade of Indian Ocean and the successful southwest monsoon. Okay. So one paragraph about La Nina also you can take it. Next heading, write it as La Nina. Kindly write it as La Nina. La Nina is the normal condition of South Pacific Ocean. Is the normal condition of South Pacific Ocean. The normal condition of South Pacific Ocean. The next sentence you can write. Generally, or you can say, even the word generally you can strike it off. You can write it. When the cold Peruvian current, gets re-established, and the cold Peruvian current gets re-established along the Peruvian coast, it is referred as La Nina. It is referred as La Nina. La Nina condition establishes a strong southeastern trade. Establishes a strong southeastern trade of Pacific Ocean and eventually favors Indian monsoon. So my dear friends, normal condition is La Nina, normal condition is favorable. Reversed condition is El Nino, it is unfavorable. All right. So what is El Nino and La Nina? That also we have taken. With this, we are also completing this monsoon, my friend. Okay. Only the climatology as such means the world climatic classification is left. Small topic, right? Some other day we'll just try to complete it. So somewhere I'm just concluding the class here at this moment, my friends. So thank you for being in the class, right? Some other day we'll just meet. Thank you, my dear friends.
Thank you, sir.